We are now very excited to be joined by Fleur Hasaart, our second keynote of today. A little introduction on Fleur is she currently works as the manager of the data science department at CZ Health Insurance. She holds a master in international economics from Tilburg University and a PhD in health economics from Maastricht University. Within CZ, her department focuses both on using AI for the enhancement of customer service and on using AI within the field of healthcare. Now, making data science a key element in any company strategy is easier said than done. So how do you go from a few loose prototypes to a coherent set of AI models that are actually used within your company? In this talk, Fleur will share her learnings on CZ's search from prototype to implementation. She will demonstrate her learnings with a use case CZ is working on now about medical claim authorizations. It's my great pleasure to welcome Fleur onto the stage. And I'd just like to remind everyone to use the Q&A functionality in the Slido tab. And yes, without further ado, over to you, Fleur.
Thank you so much, Jean. Let me share my screen. Okay, I'm sorry, this is the first time I'm using this, and now I practice this. But how is this not working now? Is there any help there, Jean? Ah, yes, there it is. Yep.
Excellent.
You can see it, right?
Yes, we see it, and
Perfect.
everything is perfect.
Thank you so much. Thanks for the wonderful introduction, and also thank you so much for inviting me to talk here. It's my great pleasure and honor. I have been in meetings with only men today, so I thought what a perfect opportunity to spend my afternoon talking to presumably a lot of women in data science, which I very much enjoy. And also I gave another talk last Wednesday at a management event about data and analytics, and I was the only female speaker and female discussionist there. And there were a lot of speakers and a lot of panelists. So I think it's great that we're organizing this and very much needed, unfortunately. So as Jean said, I work at CZ. That's a health insurance company in the Netherlands. So we have a government question to control costs and to ensure access to healthcare for all of our members. So just a little bit of detail about CZ. We are based mostly in the south of the Netherlands, and we have around 2,500 people working for us and 3.7 million people being insured. And we have actually a lot of data because we have all the claims data of people. We have all the customer contacts. So there's a lot of data that we can use to enhance our goals and to get towards our strategy. And we've also identified a number of trends that will affect the strategy of health insurance companies in the coming years. And using data science there will definitely be crucial. And let me just shed some light on the challenges that we're facing. So we are currently having members that are obviously expecting 24 digital and personalized services, as they also see in other companies where they, for example, shop online. And this is not something that we were built for, right? So we're going through a huge digital transformation to make sure that happens. We're also in a system where solidarity is under a lot of pressure. So is market competition the system to organize healthcare within the Netherlands? Also in the coming elections, that's going to be a big theme. And as a lot of the bigger institutions in the Netherlands and worldwide, we're also looking at the new entrants and the rise of fintech and what that will do for general insurance companies and healthcare insurance companies. We're actually doing a really nice PhD research with JATS, Data Science University in Den Bosch, about the future business models that health insurance companies can look at when they're trying to strategize for what's to come. So that about the background of CZ. So within my team, the data science team, we typically work on two types of cases. So we work on cases that are related to service, and we work on cases that are related to healthcare claims. And I'm going to give you two examples of what we mean with that. So the first example is has to do with service towards our members. So yearly, we get a lot of emails from people that are asking us to change their address. They're asking what the best policy is. They're asking what the best provider would be to go to. Sometimes they're asking, is this covered, yes or no? When am I getting my money back, etc., etc. All those emails are manually sorted into the right workflow to go into the right department. By this manual labor in between, a lot of time is getting lost because it now takes on average up to 2 business days before an email can get answered. So what we've done is we have all this beautiful labeled data, right? Because we have all the emails from the previous years and we know what workflows they were put into. So we've trained an algorithm to automatically route the emails towards the right workflow. This was our first really big project, and it cost me blood, sweat, and literally tears to make sure that this would happen, because it was, we used a neural net, we used a black box model that needs to communicate with one of our biggest customer contact system, our email system. So this was super, super exciting for CZ to do something with Python code, a language that no one speaks, with an intransparent model for something so crucial, namely the communication with our members. So this was our baby project. And it took us over 2 years to make sure that this got implemented. But we've learned so much here. And we're actually now at the moment making sure that the model is going to be even better. And we're including more and more departments and more emails. Another type of data that we have is claims data. So from all our customers, the 3.6 million, we know all the medical claims that they get. And to give you some idea about what all is, we get roughly 250 million claims a year for 3.6 million people. So that means that we have a lot of information on the different providers that our members go to, the types of care that they consume, the amount of care that they consume, and maybe also information that will help us create like a care journey on how they travel through the landscape. So what we did last year is that we used all that information to cluster patients into groups of similar resource use, so that from there we could predict what their future costs will be. And if we have a little bit more information on the future cost, we can make better contracts with hospitals, because we will know a little bit better about what will come and how much care we need to contract, because that's one of our main tasks, right? To ensure accessibility for all of our members. And that includes making good contracts with hospitals on volume, on quality, but also on price. So those are the 2 types of cases that we're working on. And that already brings me to my first learning. So I'm gonna every time share a little bit of what we've done on a use case and then come to a learning that I hope will be interesting to share with you if you're setting up your data science department or your data science strategy in a future company. So in the first year of my department, we experimented a lot. I think we did over 35 different cases, from HR to finance to predicting how much personnel was needed to detecting fraud, etc. That gave us a super broad knowledge of what was happening in the company, which departments wanted to work with us, which departments thought we were a little bit scary, what data we actually had, how good the quality of the data was, etc., etc. But in the end, if you don't have the right domain knowledge, and you don't really focus on certain topics, you will never really get as mature or as effective and fast as you want to be. So after a year and a half of broad exploration and experimentation, we decided to focus on the service category and on the things that we can do with claims. And that really helped, because we can kind of divide the team also between those 2 topics, and then have them learn about the domains, have them understand the data. And then from there, they can also come up with other questions that the business might not have, and that they will come up with because they now know the data and they know the problems and they know the business processes, etc. So broad experimentation and exploration, and then focus back to areas where you can really start building on knowledge. That brings me to a use case that I wanted to talk about with you this afternoon, and it's about predicting authorization requests. An authorization request in Dutch would be een medische beoordeling. And for some types of health care in the Netherlands, you need to first request it before you can get it from your provider. For example, this goes for specific dental care, for orthopedic shoes, for a neck brace, for all different types of healthcare. And this is required by law. Actually, it's not something that we're making up by ourselves. And it's the same for all the health insurance company. It's kind of a lengthy process, and it's very high on administrative burden. So here you see in Dutch the text on our website, and it says you will receive within 10 working days a reaction to your request, and sometimes we need more information. So what we thought is, what if we use a data science model to immediately, when a request comes in, and I'm going to show you a request later in the slides, just see if we can decide if we can, yes, grant this, or no, we unfortunately cannot, or we need more information. And if we can shorten the waiting days here, this will greatly improve the customer satisfaction, and it will also increase for us the efficiency of requesting an authorization. Before I start explaining you here what we did, I want to really share with you that within this domain, and I think also later we're going to touch upon that a little bit in the group discussion, the medical care domain has, of course, is super sensitive because we're talking about people who are granting access to healthcare. So ethics, GDPR, legal stuff, it's all super, super important. So we made a framework which is based on Dutch regulations or European regulations on what we have to think about when we're making a project. And we want to, for example, make sure that we have some human autonomy here and control so that our insurees understand that sometimes when they make a request with us, a machine will look at that request. We also want to make sure that it's super robust and super secure, because obviously we would not want a data leakage about medical care authorizations. Obviously, all privacy restrictions and regulations need to be super in place. Transparency is also something that is something we discuss a lot, because when you're setting up a data science department and you're thinking of enhancing the use of AI in your department, very soon you'll go to neural networks and to deep learning, and it'll all give you super great results. But if you're talking about something as sensitive as this, granting access to a type of medical care that someone needs, we feel that we should not use black box models. We felt that we should use very easy to understand models. So we're using decision trees in this example. It's not the fanciest data science, far from it, but we feel that it's super necessary to be transparent in this sensitive process. We also want to make sure that we're preventing unjust bias, right? We don't want to exclude certain groups. So an example here is that we're trying to personalize the treatment of our debtors. So people who are in debt with CZ, and we want to make sure that they will not get into a lot of trouble with other institutions and help them set up arrangements that they can stick to. In personalizing that approach, which we are required by law to personalize it, you want to really make sure that you're not using variables here like maybe postal code that might say a lot about someone's ethnicity here that we obviously don't want to take into account when we're setting up policies. But you want to be super careful here that you're not excluding or unjustly treating certain groups. So it's something that we always think about before we set up a project. Social well-being, accountability, the same. So this is super important. And all those conditions need to be met before we're making and implementing a use case. Back to my example. This, and don't be shocked, is the actual current situation. So pictures like this and forms like this, which cannot be read very properly. They're not super good machine readable. There's even written text at the top of this page. You can see these are sent in to CZ, and then they're scanned in, and an employee gets this on her screen, and she has to then look at what's in the form, who are we talking about, what can I find of this person in my database, what are the business rules for this type of care, and then make a decision. So when we first took up this project, and this is Yeah, already almost 5 years ago, just before I started as the manager, we spent a lot of time on OCRing this firm and really looking at very fancy techniques to make sure that we understood every little field that's in this form. That didn't really lead to something that was very scalable because the forms were all so different and per type of care, everything was different. So we kind of abandoned the project. And we have a very strict innovation funnel. So if after a couple of weeks we don't see any value, we abandon the project and we move to something else. But the project kind of always stuck with me in the back of my head, and it didn't, I didn't feel like I really helped that department. So last year we revisited this problem and we said, what if we look at this completely different? What if we don't look at the form, but what if we look at the data we already have? So we're not going to look at specific medical stuff that's written down. We're going to just look at all the claims we already have in our database, the social demographics that we already have about an insuree, what the provider that's requesting the authorization did in the previous years, and really come up with an idea from there. And that's learning number 2 that I wanted to share with you. The real value of data science comes together with process redesign. It wasn't until we decided that we could change this process that we found the real value here. And the real value here is that we can just look at the data that's already in our database, and the providers don't have to fill in that form. Their administrative burden can be much, much lower, and the answer can come a lot sooner. And we can make do with data that's already there, which has already been collected, and that's going to be reused also for the goal of executing health insurance. So it's also legally okay to do this. But you have to first feel and earn and get the freedom that you can talk with someone about their process. If you immediately start talking about difficult OCR or about neural nets and you don't really understand what the pain is and what's going on in the process, then you will never get to the phase where you, together with the business manager and the employees there, talk about what would an optimal process be here if we can make use of data science techniques or AI. And this is something that's really hard, but when you do it, it's really, really nice because then you can really get the value out of your data science project. And I'm going to show you a little bit how we did that. By the way, I have a helicopter flying over, so if you hear that, it'll be gone soon. So to build the first prototype, this is the flow we use. So obviously we start with data, we build different models, we build a model selection dashboard that I'll show you because it was crucial in making the right decisions with the business. We made an API to later be able to connect to the transactional systems. We made a supporting tool for employees where the employees can fill in all the requested variables and an answer will be spit out. And we also made a dashboard that can track the results and make sure that we're not making decisions that are not good or if the accuracy of our models is going down. So let me start with the tool for the employee. What we've done in the beginning, because we wanted to really go fast and have a very short time to market, is that we made a standalone tool. We just made a dashboard with Python where the employee could fill in a client number, a type of care, and a provider number, and then the underlying data science model, in this case, the chosen decision tree, would give an approve or it would give an I don't know, investigate. And that's something very important that was also in my ethics slide, is that my model will only say approve or I don't know. So we do not want the computer to say, no, you do not get access to this medical care type. You will only be able to get a yes, and then it will automatically be approved and the process can go on, or it will go to one of our employees who will then do a manual check on everything and can then say, okay, I'm going to approve this, I'm going to need more information, or I'm going to decline this. Also, to make sure that we're not falling into some self-fulfilling prophecy where we're continuously making the same bad decisions, 10% of the requests are going to go randomly into manual checkup. And we're going to keep this going for quite some time so that we're sure that the model is going to continue to learn from the actual employees who have the knowledge. After results, we also not only a dashboard for also a dashboard for the manager. And this is a dashboard that we made with our Shiny, which really helps us if we want to do some fast dashboarding and show the business managers what we're working on. And what you see here is just some management information, how many requests were handled by the algorithm, how much did we approve, how much had to go to manual check, etc. But it also shows you metrics about the actual business value. So it shows you how much waiting time did we reduce, how much cost did that save, but also how much extra cost does this lead to? Because if we have false positives, if we have models that will sometimes say, yes, grant this type of care, whereas a human might not have said this, then healthcare costs will go towards that medical authorization. And that is something, I'm going to also talk a little bit more about that later, which is kind of hard to understand for an operational business manager, because he would just tell us, okay, I don't want a model that has that is not 100% correct. I only want the best models, and I will don't ever tolerate if it's not doing 100% correct. So that's really a process that we had to go through with our business. But before I tell you more about that, let's start a little bit back at the beginning. Data. I told you that we were only looking at data we already have, and that's indeed what we did. We looked at socio-demographic data, and as you can see here, sex is in there, age and type of insurance. We actually doubted for quite some time if we should include sex, yes or no, but there's some specific authorization claims where there are different business rules, which are also very good explainable, that we're differentiating here. So we decided to include it, but we had a lot of discussions here. We're looking at history. So we're looking at past claims that people have had and past diseases that people have had, and also past authorizations that people have had. Because if in the past you've had an authorization for a specific type of dental care, chances are that the second authorization will also be granted. And there are many more examples like this. And also, of course, the other way around. And we're also looking at your provider, so your healthcare provider, and see how well he or she has done in the past. And if from all the previous authorizations that were requested, how high was the percentage of those that were granted? Because that tells us something about maybe even like the administrative quality or even the ethics of a provider when granting authorizations. With all these variables, we've then decided to make a number of different models. So we make a reference model, and then we have some different additions where we also make a claims model, where we add the claims history, we make a provider model, or we add the provider score, and then claims provider model. You can see what we did there. And then per type of care, we're looking at what model performs best here. And then we've, of course, looked at different performance metrics and talked about that with the business manager. And the business manager can choose per type of care what model he or she will want. And we made a pretty robust architecture here also with the use of MLflow and Docker. And we can every day for every type of care deploy a new model, which gives us great flexibility in making sure that we're always doing the thing that the business manager will want, and which is best for the insuree, best for the administrative burden, and also best for healthcare costs. So it's this triple aim that we're continuously looking at. And the business manager can also really look at the dashboard and see the performance of the chosen models. So this is something that we've went through with, I think it's a Lean Six Sigma expert that works at the department, but also the operational business manager. And this is pretty hard, right, for an operational business manager to understand this and to read this tree, and then to see what the economic effects would be of choosing something, and also what the waiting days effects would be of choosing something. And we really helped and guided the business manager in choosing the models here. And together we also kind of journeyed and understood that the best data science model is not always the best business model. So we really had to make sometimes choices that the data scientists wouldn't completely understand, and vice versa. I'm very sorry. I'm missing my last learning. There should be a slide here. So a learning here is that understanding AI from a business perspective is really, really necessary, because it's the business manager that has to make the decision if something is going to be implemented. So taking the time to have your business manager understand the consequences of implementing AI is hard, but very much worth it. Because if she doesn't have the trust in your model, and the trust in that it will do the best for your company, then there will never be a go-ahead to deploy your model and to actually use it. And there will only be value, right, if you're using it in the real world. The value is not me having 16 prototypes in my sandbox environment and making sure that we can show super cool stuff in talks like this. The value is in actually using it in the real world. So making those decisions together with the business managers is really crucial. It takes a lot of time, it takes a lot of effort. It might even take some education. We organized a one-day course, kind of like a data science for dummies, where we explained everything that you need to know when you're first working with data science, just some basic information. And for the coming year, we're going to do a next course to really help people understand even more about this beautiful topic. And this brings me to my last slide. Back to the use case. How did we do? Performance was good enough to go live. So we're actually using this for a number of types of care. We're going to expand that to other types of care. And we're definitely going to keep working towards the bigger goal of redesigning this process and making it even smoother for the provider and making it even smoother for the insuree, by maybe even adding proactive services or enhancing the user experience. Maybe not all data science, but really something that'll help towards the end goal of making sure that our members get the best experience possible. That's the one I wanted to share with you today. So I'm going to stop sharing.
Fleur, thank you very much for your talk. I think we got a lot of questions, so I'm gonna go through them based on the like.
Sure.
So if you want to put any question up, I think from the audience perspective, just put like in the questions that you want to bring them further up. One question is, do you link to data from other organizations? For example, healthcare providers.
Yeah, so sometimes we can use data from other organizations, but we're not, it's not always within the legal framework to share them. So what we've done is we've worked greatly on something called privacy preserving analytics, where you can combine data through multi-party computation without people seeing each other's data. And there, for example, with a hospital in the south of the Netherlands, we're trying to find evidence for the effectiveness of e-health by combining data that we have and combining data that they have, and even combining data from the CBS, which has more individual detailed information about the socio-demographics of the patient population without all of us seeing each other's data. So it's a really cool chance that we're looking at right now.
Great, thank you very much. And one other question comes from Hinda. She's asking that you mentioned that we are required by law to personalize our approach. Could you tell us more about this?
Yeah, sure. Yeah, so we have a lot of authoritative bodies that are looking at health insurance company, like the Dutch National Bank looks at liquidity, etc. We have the AFM about market competition in financial markets. We have the Autoriteit Persoonsgegevens about how we deal with privacy, but we also have the Dutch Healthcare Authority, and they look at all the health insurance companies, and what they said a couple of years ago is that they felt that we should personalize our approach towards our debtors, right? So people that cannot pay their policy, and that we really should come up with individual plans, but also individual recognition beforehand with predictive analytics who might get into trouble. So that can be of super high social value, because if you can save people from a financial disaster, that's super important. And from research, we know that the first thing people stop paying is health insurance, because it's a lot of money and nothing really happens if you stop paying, because you will be covered, no worries, right? This is something that we do. in the Netherlands. But it's a super good indicator for future financial problems, for example, about rent. If you stop paying rent, you'll be evicted. So we could use our data to target people that might get into trouble. So from there, you can do a lot of good, right? If you can help those people. But it can also very easily become some sort of profiling hunt with variables you don't want to include in something like this. So that's the tricky part.
We have 1 minute, so and there's a question that is getting a lot of likes, so I'm going to pause it, but maybe it requires a bit of a longer answer. We try to see how far we can go, but Sally says that it's great to see that legal and societal issues are discussed, and she wonders how developing personalized insurance fits to the basic idea that health insurance is about sharing risk and solidarity.
Yeah, so it doesn't fit, right? So it's not also not something that we work on that much. So what I meant with the personalization is mostly in service, right? In a personal approach on what your next question might be, what would be a good provider for you, but it's not on making individual risk plans, because that is definitely 100% against the idea of solidarity and making, so the idea behind insurance. We have experimented a little bit if it would be smart to recommend a product for someone, like based on other people like you or based on consumption like you, but very easily you get towards this problem of the fact that it's a risk-based product based on solidarity. And we very much would like to keep it that way.
Thank you very much. Thank you very much for your talk as well. I'm going to leave it to Jean, and there are more questions for you if you would like to have a look at them or
Sure,
do some. Thank you very much.
Thanks.
Yes, thank you so much, Fleur.